Hey guys, welcome to the new lecture of study data of algorithm. In this lecture, we will discuss about time and space analysis of algorithm. So, first thing, we how we calculate how efficient an algorithm is. Let's say we want to find or we want to measure efficiency of an algorithm using efficiency of algorithm. So how to measure an algorithm is good or not? We can measure it by taking account time. It means how long the algorithm take or how long the running time is. So we can say how long the algorithm takes. And second thing about efficiency of algorithm, we should take account space. It means memory requirement of that program. Memory requirement. So if we want to know the efficiency of algorithm, we should know about its time complexity and space complexity. And we know time depend upon processing speed. So it is impossible to change for a given hardware. The time complexity of an algorithm is fixed. Of a given algorithm is a fix, and it only depend on processing speed. It is impossible for change any given hardware depend upon processing speed, you can say it. And space is a function of memory, available memory. So it is function of available memory. Nowadays there are lots of large memory or big memory system are available in market. So for making a good program, we should neglect space complexity and we should focus only upon time complexity, how much our algorithm should work, how much faster our program is run. So main focus designing and in designing an algorithm should be given to only time. And as we said, time depend upon processing speed. So different procedure will have different processing speed. And if you take a procedure, if you will take an algorithm and you run that algorithm in two different system, then running time of that algorithm will be different in both the computers. So instead of taking running time, we will take only how many steps an algorithm takes. So keep in mind, instead of looking total running time, we will only focus about how many steps the algorithm takes. So now let's move toward asymptotic notation. Basically, asymptotic notation are some notation which are used to find upper bound, lower bound, or time complexity. You can say time complexity of a algorithm or a program. So, first notation which is used to find time complexity is upper bound. It is denoted by big O. Big O. So, what is upper bound? Let us say we have prepared an algorithm or given an algorithm, and algorithm have an input and denotes input, and y-axis denotes time. So let us say an algorithm move according to this function. Time complexity of algorithm is denoted by this curve. And if we have find or we have found a CG of n such that for every input T of n is less than equal to Cg of n for every input. Let's say for every n greater than n naught. If Tn is less than Cgn, then we can say it Tn equal to O of Gn. Actually, big O give you upper bound. You can say if we have six. Don't confuse it too much. You will understand it easily by seeing some example. Let us consider an example. Let us say take Tn is given 3n plus 2. Sorry, Tn given 3n plus 2, and we have to find what is the upper bound of Tn. So Tn is given 3n plus 2, and let's say it is less than C of G of n. Then we know 3n plus n less than equal to 4n. 4n is less than or equal to 4n. If n is greater than 2, then 3n plus 2, 3n plus n is always greater than or equal to 3n plus 2. Then 3n plus n is always greater than or equal to 3n plus 2. So we can say 3n plus 2 always less than or equal to 4n. For n greater than or equal to 2, c equal to 4. Since T of n is O of G of n, so by using this method you can easily find upper bound of any function. We will see some asymptotic notation more in next lectures, and it is very easy. After solving it, you can find easily time complexity of any algorithm. If you have not subscribed our channel, please subscribe right now. Thanks for watching.